this lecture will contain some basics about production engineering. So this includes completion stage and some production stage. Now first understand what is exploration. Exploration is in this phase you are actually calculating how much oil and gas is there and where is their location. Then during a drilling stage actually you are trying to install the drilling equipment and completion equipment, and finally you are completing the wellbore so that it will be ready for production. Now you got production on the surface, and then you want to send that fluid to the refineries, but refinery will not take the fluid having mixture of oil, gas, sand, water. So you have to separate. So how the process will go on, I'll explain. So during exploration, I already explained, this is actually evaluation process. Then you go to drilling stage. In drilling stage, you install equipments. Drill and install equipments. And during completion stage, actually you make the wellbore ready. Make the wellbore ready for production. Now you made wellbore ready for production, but still you cannot produce because you have to connect this one to surface production systems. So from let's say wellbore is here, you put one tubing, casing already done and cemented here. Okay, now your tubing is producing well. Now it is passing this fluid to wellhead. Okay, and there might be Christmas tree also. Christmas. So Christmas tree is nothing but several valve arrangement and flow conduit, so that fluid coming from the wellbore through wellhead to the Christmas tree, there will be several valve arrangement. So some valve will be allowing fluid to go out of the wellbore, some valve will be allowing fluid to enter into the wellbore. So there will be several valve mechanism, I already explained there. So if you want more information, you go back to the previous lectures. Then from Christmas tree you got fluid and that will be passing through one choke. From choke there will be separator system. Separators. After separators there will be downstream or pipeline mechanism. Pipeline or maybe your tanker transportation or some other means of mechanism to transport it to refineries. So from refinery you go, you send that oil whatever you separated and you distilled based on petroleum, diesel, grease, naphtha, you send to customer. Customer means like you are the customer, you have a bike, you have car, you have Indian gas cylinder, so you are the customer. So finally you are getting the oil or gas whatever and you are consuming it finally. So this course basically focusing on completion stage and production stage. So now go to the production stage. In production stage you have to install separators. So separator, like say you have wellhead, then from choke you are getting fluid and you have one separator. Why separator is required? Separator is required because you are getting high pressure fluid from wellbore with oil plus gas plus water plus sand. So all these four phases will be mixture when it is coming from the wellbore. Now in separator, in first stage separator, normally it will be two-phase separator. First remove the free gas or any dissolved gas is there. So gas, and it is one pressure vessel actually. In pressure vessel, if you have one pressure vessel, you put oil and gas through inlet pipe, and there will be exit pipe for oil, and on the top of the vessel there will be one hole. So their hole will have one mist extractor, and you will get gas, because this gas is lighter weight. So, gas will be escaping from the top hole. From the bottom or near bottom hole, you will get liquid. Liquid means oil, water. A sand also can be there, or sand can be settling at the bottom. So, this is two-phase separator. Two-phase separator. So, here you are getting oil plus water, maybe sand also there. Okay, and gas line may contain maybe water vapor will be there, gas will be there, some H2S will be there, carbon dioxide will be there. So, how to separate gas, I will explain later. So, when you are getting oil plus water with sand, then you pass this one to three-phase separator. Three-phase separator. So, in a three-phase separator, what you do? You have gas extraction line here again, natural gas you are extracting here. So, this is called mist extractor. This sieve like structure is called mist extractor, M-I-S-T, mist extractor, C-T-R-A-C-T-O-R, extractor. So, mist extraction means it will be holding all the, if any water particle or liquid particle is going through this channel or through this mesh or extractor, this will be colliding each other, and when colliding each other it will make bigger particle and it will be falling down, and gas which is lighter weight, it will go through the gas line. And another part, it will have one layer here, one layer here. And I already told that oil is low density fluid. Low density fluid means oil will be floating over water, and water is here. Okay. So, what you do during separation stage, you take water separately and you get oil separately. So, here one thing to know, you have to know that oil and water, that level maintenance is very important. If oil level, let us say your exit flow valve, here will be another flow valve. So, if exit flow valve is not controlling flow properly, then what will happen? Oil line or oil pipe, out pipe will have lots of water or gas, because you are not maintaining the level of oil. Let us say level is going down, 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 down. After a certain time, oil level is below the entry point of exit valve. So, in that case, gas will be coming out from your oil channel. So, oil channel will have gas. But while if you reduce further, then if water level is like almost 0, then in that case your water pipe will have lots of oil, or if oil also not there, then it will have gas. So, you have to maintain the oil and water level properly. So, there will be one level controller. This is called level controller. Level controller. The term is called level controller. Here water also will have one level controller. Okay, level controller. So, level controller, like you have seen toilet flush chamber. So, if flush it, if press a button, so water will go through this chamber, and it will be circulating continuously, and once the water from the upper chamber is completely drained down, then again it will be closing one valve, again it will allow fluid to go up. Again, when fluid is reaching up to certain level, again it will be close the valve, entry of water entry valve. If it is not closing the water entry valve, what will happen? It will be overflowing on your whole bathroom or toilet area. So, there will be one mechanism which will be the valve will be working for only certain region only. If it is completely 0, it will be opening the valve, water flow will be coming into your that chamber, and when the valve is moving up, so again it will be closing the path. So, within certain range only the valve will be working. So, here also similar mechanism will be there. This is called level controller. Within certain level of water or oil level, it will work. This is called level controller. Okay, and this is called inlet. So, from wellbore, you are getting very high pressure fluid, let us say 100 bar, for example. Then in first stage, you do two-phase separation. You remove all the free gases or dissolved light gases, condensate, if you possible you can remove as much as possible. And there also will be one mist extractor, so that liquid should not go into gas line. Once you separated gas and liquid, so in there some pressure drop will be there. If you are not reducing pressure, then actually two phase will be it will be a mixed phase, so separation will be difficult. So each stage actually you reduce pressure, but then you separate oil and gas. Okay. So first stage reduce little bit pressure, so whatever gas forcefully dissolved in liquid, so that will be going out, or free gas is there, it will go out, it will go to gas line. And you got liquid at higher pressure, still it will have gas, it will have sand, it will have solid, then you pass to the three phase separator, next phase separator. So separator will be separating it again, because pressure is going down, so again some gas will be going out from liquid. While liquid release the required gas, the gas will go to the gas line, and liquid will have two phases, water and oil. So you give sufficient time water and oil to separate. So how they will separate? Because the density difference, oil will try to float over water, but in some cases oil will not try to flow because of certain chemicals such as wax and asphaltene is there, then it will create a mixture of oil and water. So in that case you have to add maybe some chemicals and you have to separate. Normally because of gravity, water is a higher density, higher gravity, oil is lower gravity, so oil will be floating here, water will be here, and you have to give sufficient time. If you are not giving sufficient time, then the water, whatever water is there, water will contain oil particle or oil will contain water particle. And how much time you have to give? That is called retention time. How much time it will be there here? It is called retention time. So retention time is that, like say if you give 15 minutes to retain water and oil mixture in the separator, so they call retention time. So in 15 minutes maximum oil particle from water, water particle from oil will be separated, and you take oil and water out. And every time you have to control the level. If you are not controlling level, then it will be creating much difficulty. And I was teaching the sand control part. So if you are not controlling sand properly, then you will have lots of sand. So that sand will be getting deposited into your separator system. So that will be blocking your flow path, that will be eroding the surface. The separator system may not work because it will have small valves and nozzles, and lots of bend and turns, and erosion, blocking will be there. And again, if you have H2S gas, again you have to select the material property, because H2S plus iron, if you have a hydrogen sulfide or H2S gas is there, so H2S plus Fe, so it plus oxygen, so H2SO4 it will be producing, or H2SO3. So this H2SO4, H2SO3 is the salt of iron. So salt of iron is softer than iron. So softer than iron means if any small force is given on this softer part, it will be getting removed. So gradually iron surface will be getting reduced because it is producing salt because of reaction with sulfur. So in sulfur and hydrogen, sulfur and iron is reacting, it will create hydrogen sulfide. It will create sulfuric acid or sulfurous acid. That acid will be reacting with metal, so that will be harmful. So your metal, like this pressure vessel, these separators are pressure vessel actually, and piping also should contain lots of pressure. So at high pressure when you are working, and if there is any corrosion because of this one, then your system can fail, it can be very much unsafe. So if you have hydrogen sulfide, you have to select material property. So once you selected material property, then you install whole system as it is. And if you have sanding probability, then you have to check how to handle the sand. If you are not handling sand on the surface, then again there will be deposition, erosion rate. Again sand plus H2S. Now we consider, like say you have sand also, you have H2S also. What will happen here? So erosion and corrosion will be happening together. Okay, erosion and corrosion. How it will happen? Erosion means when soft material salt you created using H2S and Fe reaction, so that reaction product is very softer. Now you have sands, you hit with sand, that softer material. What will happen? Softer material will get removed from that area, and again fresh metal surface will coming up, and it will be reacting with H2S or S, sulfur or hydrogen sulfide. So fresh metal surface will be reacting, it will create softer material, ferric or ferrous sulfate, then again that will be getting removed, again your reaction will occur. So, corrosion and erosion both work together. So, your pipe will be rupturing quickly, okay, and this salt also will be blocking somewhere some equipment. So, both way it will be disastrous. So, if you have H2S, you know, or if you have sand, then you have to handle properly, you have to design your equipment properly, so that system can be safe and it will be working for longer duration. Separators, oil, gas, water. So, you have seen like wellhead. Again, I will draw from wellhead. This is wellbore. Okay, wellbore fluid is coming, and from wellhead or Christmas tree, you are getting this fluid. And first, you are facing choke. All right, choke valve will be there. From choke valve, you are having one separator. Okay. So, that separator may be two phase first, two phase, then it will go to three phase. Okay. So, there will be vertical separator, horizontal separator. So, horizontal separator means longer it is horizontally long, and vertical means vertically long. Okay. So, based on requirement, you use vertical or horizontal. Normally, the first stage will be horizontal separator, second stage will be when three phase separation is going on. So, that time you can create vertical separator. Two phase normally it will be horizontal separator. So, mist extractor I already told, it is going like this, three phase separator. Now, gas again, all right. Then you are getting oil out, water out, because oil layer is here, water layer is here. So, water, oil, gas. So, I am denoting as a G as a gas, O is oil, and W is water. Now, you got oil. So, how to separate oil? So, oil will have water particle and gas also, because pressure is still high. Let us say this is 100 bar pressure, and after first stage maybe it will be 50 bar pressure or 40 bar pressure, then 20 bar pressure. So, pressure is still high, higher than atmospheric pressure or normal pressure, temperature and pressure. Normal temperature pressure in oil industry, they assume that 14.7 psi or 1 bar and 60 degree Fahrenheit. 14.7 psi they called as a standard pressure, and 60 degree Fahrenheit as a standard temperature. Okay. So, oil and gas industry, they will be assuming as this is a standard condition or surface condition. So, all the parameters will be measured based on surface condition, and if they are specifying other than the surface condition, they will specify that it is reservoir condition or certain pressure and temperature. If you are not specifying pressure or temperature, then if fluid property actually you cannot explain, because at certain temperature fluid will be dissolving certain amount of gas or releasing certain amount of gas, at certain pressure also same thing will happen. So, whenever you are specifying wellbore fluid from wellbore to surface, you have to specify which condition, whether it is reservoir condition or surface condition or in between somewhere. If you do not specify, then it will be vague or it will be error. Then you got oil. So, oil will have again separator system. Why separator system? Because still pressure may be 5 bar. Okay. So, when 5 bar pressure or 14.7 psi means 1 bar. Okay. So, whenever you are learning oil and gas any course, so you have to learn the field unit. Field unit implies that unit people use when they are working in the field. So, normally it will be like 14.7 psi is in standard pressure. So, psi they will be using as a unit, not Newton meter or meter square or centigrade temperature. So, they will be using Fahrenheit, psi, they will be using gallon, barrel. So, I will explain details later, but you should remember these are the field unit. So, whenever you will be specifying in oil and gas fluid properties or anything, we will be using the term in field unit. ONGC normally they will be using both, basically SI unit they will be using, but US normally they will be using field unit. US dominated in oil and gas industry, like for example big companies headquarters are there in the US. So, whenever they are going for business to any country, so normally they will be bringing that unit also to that country. So, normally field unit is very much popular in the oil industry, although the conversion terms are very difficult to remember. For example, gallon to barrel, barrel to feet, cubic feet. So, those terms as if you are willing to work for oil industry, you have to remember conversion thing. I can remember when I was working for an oil industry in the UK, in the Aberdeen. So, there I was getting all the data in field unit. Now, for my own calculation, what I was doing, I was trying to convert all things in SI unit. I will do all the calculation, then final when I will be delivering, so I will be converting it field unit and will be delivered to the company, because if I do not give into field unit, they will not understand. But for my own ease, for own comfort, I convert all units into SI, from SI to field. So, that makes my life easier, because during calculations lots of several stages of calculation, several sheets I have to prepare. So, that one I used using SI. I got field unit, I delivered field unit, because field unit they will not understand. If I give SI unit, they will not understand, only field unit they will understand. Okay. So, let us say still 5 bar pressure or 5 into 4, 70, 72 bar PSI pressure is there. So, in that case what you do, you put again in another separator, and you put one mist extractor here, and you take gas out, still some gas, dissolved gas will be there, right. Now, you have oil here and you want to separate water. How to separate? So, sometimes you may have to add chemical, or you have to use some heater treater. Heater treater means you have to increase temperature, so that viscosity can be changed. And why viscosity relevant for separation? Viscosity relevant separation because if you see particle settlement, settlement formula, they will have one viscosity term. If higher viscosity is there, say oil you have and water particle is there, water particle high density, so water particle will be falling down slowly. And if you have high viscosity, viscosity means resistance to flow, viscosity will not allow the particle to move faster. So, higher viscosity means particle will be hold here, it will not allow to move further. So, what you have to do, you have to reduce viscosity actually. So, viscosity, to reduce viscosity, one option is there, you increase temperature. So, the oil viscosity will change. So, that time water will be falling at higher rate, and with temperature increase, water viscosity will not change much, but oil viscosity will be changing much higher rate. So, increasing temperature actually you are increasing settlement rate. So, water particle whatever they are in oil, water particles, say these are, and these are my water, and this is oil, this is gas. Okay, gas is going out, oil will be going like this, and water will be going like this. Okay, so if you have higher viscosity, you have to reduce it. So, if you reduce it, your settlement rate will be quicker. That means if you take certain amount of oil or gas inside a separator, so it will be staying for shorter period of time. So, your productivity rate will be higher. So, fluid flow rate will be higher. But if it is taking very long time, so 2 days, 3 days to settle some particle to bottom, that means water is mixed in oil, and water is not going quickly. In ideal condition, oil water will not make any multi-phase situation where water will not settle down. But if sometimes some chemical hinders, for example asphaltene and paraffin, they are surface active agent, so that they will not allow the fluid or water particle to collide each other and to make bigger particle. So, if you have bigger particle water particle bigger, so it will be settlement rate will be higher. So, viscosity reduce, particle size, particle big size. So, big size will be helping, okay, lower viscosity will be helping, and collision rate. If you can increase somehow the particles should be colliding each other, for example you use electrical field or some other means, then in that case when collision is occurring, so the small particle will make bigger particle. When bigger particle is there, actually it will be settling quickly. So, make bigger particle. You have to lower viscosity, you have to increase particle size, you have to increase collision rate, so the particle size will be increasing. So, in that way if you can reduce settlement rate, or you can increase flow rate actually. Okay. So, settlement will be quicker, increase flow rate, so your productivity will be increasing. Okay. And if your settlement rate or time to take to settle certain particle is high, so in that case your flow rate must be lower, so that particle the fluid will be staying longer time in the separator system. Again, you cannot create turbulent flow inside. You have to create laminar flow. If you are creating turbulent flow, then particle will be in turbulent flow. Turbulent means particle will be moving randomly, right? So, if you are creating turbulent flow, then some particle is trying to moving down, again because of the random nature it will be trying to move up. So, you have to create a smooth laminar flow, so that particle will be settling slowly, smoothly, and it will be efficient system. Okay, now gas separation. So, you have seen the oil separation, now gas separation. So, I said like from separator system you are getting gas like this, right. So, gas can contain your natural gas, low carbon, lower number of carbon in atom, natural gas, and higher. So, here two things you have to remember. One thing is that when you are saying about gas means it is number of carbon will be lower and chain will be smaller. And if you are thinking of paraffin, wax, heavy oil, the more carbon will be joining together, it will be making longer chain hydrocarbon. So, volatility will be lower because long chain is there. So, particle will not try to move, okay, because of this chain interaction. But if you have very small particle, say methane, ethane, so those are 2 carbon, 1 carbon, 3 carbon, 4 carbon maximum. So, then volatility will be very high. So, in that case at lower temperature pressure also it will be in gas condition, okay. And if you have very long chain hydrocarbon, it can create paraffin, wax, heavy oil, okay. So, you got natural gas. So, then natural gas will contain further your enemy H2S and CO2. So, H2S and CO2 if it is there in the natural gas, it is called sour gas, okay. And if you can remove the whole H2S and carbon dioxide part, then we can call it as sweet gas, okay. So, if it is not there, that means sweet gas. Remove H2S or sulfur or carbon dioxide, then it will be sweet gas. So, it does not mean it is sugar, it is sweet because sour is not there, which is bitter, or sour is not there. So, this is sweet. Now, natural gas will contain one more thing, water, okay. So, when you are separating natural gas, so you have to separate sour content and water content, because Indian gas supplier or Reliance or other company supplying gas, so it should not contain water. Why it should not contain water? Because if you have gas cylinder, all right, like this, you have gas cylinder. So, if you have water content, let's say, then when you are burning gas, so gas will evaporating water. So, water will take latent heat. So, at 100 centigrade temperature, you have already studied in your school books, at 100 degree centigrade water will be evaporating or it will create steam. When it is creating steam, actually it will take heat from your surrounding, right. And if you are burning let us say Indian gas, so gas will generate lots of heat and the heat will be heating water also, and water will be producing steam. So, that steam that latent heat is taken, you cannot recover. So, that energy will be lost. So, whenever you are burning coal or oil, so there will be term called heating value, calorific value, calorific value. So, if you have water in gas or fuel, so that water will be getting evaporated or will get energy from the gas, burning gas. So, that gas is not that energy is not usable actually, that whatever water has taken for steaming. So, that means the whatever calorific value is there in the gas, some calorie will be taken by water. So, actually your total energy whatever selling by the company to you will be lower. So, companies, for example, Bharat Gas or Indian Gas, the actual company Indian Oil or those companies, they will be removing the water part, so that you get pure gas and your heating value will be more. So, whenever processing unit, gas processing unit processing gas, so they will be removing all the gas. If they do not remove, then Indian Oil will not buy that gas and they will not send to customer. So, during processing, during production phase, actually you will have contactor column. This is called contactor column. So, in contactor, what you do? You inject gas from bottom. You inject gas from bottom, and there will be a column like this. These are called contactor column. First you put one contactor column. So, gas is coming, and from top you give amine solution, lean amine solution. Lean amine solution will react with your gas having sour component such as H2S, CO2, O2, H2O, not O2. Okay, so all the component will be there in the when gas is coming, and first you pass through amine contactor column. So, amine contactor column, initially lean amine you put, then rich amine will come out. Rich amine means it will have more acidic components, such as H2S and carbon dioxide reaction happened. So, that is rich. So, when rich component is there, so that one again you process, again you make lean, and again you re-inject. And whatever gas you injected here, so whatever gas you injected here, that will have still water content because amine solution mixture was there. So, that gas again you pass through this next contactor column. There you are injecting lean glycol solution. Lean glycol solution. That lean glycol solution again it will exit as a rich glycol solution. Rich glycol solution. So, when you got rich glycol solution, again you make it lean, again you inject, and whatever gas you are getting from the second contact column, it will be dry gas and sweet gas. Because first stage you remove the acidic component, next stage you remove the water component. So, both acidic and water gone, now you got gas which can be sent to the customer. So, normally this Indian Oil or those companies will be buying, and they will be sending to the customer, like you and me are the customers. So, oil separation. I already told that oil will have water component. So, you have to separate oil. So, when you are separating oil, actually there will be issue like multi-phase situation. So, if you have multi-phase situation, then maybe you have to give more time, or you have to inject some chemical and you have to separate. So, water, sand handling, disposal. So, water separation first. Let's say why this handling is required. So, water you cannot dispose whenever you are producing from wellbore oil, gas. So, majority you are producing water actually. In the whole wellbore life, you will be producing more water than oil or gas, because water is more prevalent in the reservoir than oil and gas. Now, you got water which is not required, you have to dispose, but your environmental agency is there to catch you if you are not disposing properly. What is the criteria? Criteria is that no oil component should be there in water. So, you have to remove oil from water and you have to dispose. So, how to remove? Again, your separator is here and you create say 2 layer or 1 layer, and you got water, oil, gas, right? So, oil you are taking, gas you are taking. So, this water again you pass through one maybe skimmer. So, in skimmer actually one pond or dike is there. In dike you keep the oil for longer period. So, water for longer period, this is water. So, oil will be forming one layer here. So, using some technique you remove the oil. Okay. and water you take separately. And again, if you have still oil component, then maybe you can pass through some other type of mechanism where maybe hydrocyclone can be used or some other mechanism, and you can remove oil particle from water. Then how to dispose? If you have some well bore, you can reinject the water again, re-inject water into maybe reservoir or somewhere, maybe you can drill a hole and you can re-inject the water, so that you don't have to dispose on the surface. If you are disposing on the surface, actually the oil particle will create environmental hazard, so that is not desired. So you have to re-inject, or you can dispose after removing all the hydrocarbon content from the water, okay, or you can dry, evaporation will be occurring, and then it will be safe. Then next is sand handling. If you have sand, let's say if you are sending gas, if you are separating gas, oil, water, and bottom of the separator you are getting sand here. So what many people will be doing, many separation engineers, they will be time to time they will be opening one bottom valve where sand deposition or thick mud type deposition will be there. They will be removing, again they will be closing that one. When they are removing the sand, you cannot dispose any randomly, again environmental agencies will be there. So what you have to do, you have to remove all the hydrocarbons. How to remove? So again you can give enough settlement time. So sand will be settling at the bottom and top will be water and liquid oil layer. Another is that you can use hydrocyclone. So hydrocyclone, what is that? Hydrocyclone, actually it is like this. It is a funnel like structure, okay, it is just funnel, you have seen maybe, and one channel will be there from the side, okay, fluid entry, fluid inlet, and this fluid will be entering tangentially to this funnel. It is, if I draw side top view, it is like this, entry is here and fluid will be entering like this and it will be rotating tangentially, okay. It is touching the wall and it is rotating. When it is touching and rotating, because of gravity, fluid will try to go down also, okay. So fluid is trying to going down and rotating like toilet flush chamber, rotating, like bigger, larger diameter to smaller diameter. So what is happening, because of centrifugal action, high density particle will be trying to touch those wall, high density particle, and low density particle bechara, that they are not capable of pushing that high density particle. So what will they do? They will be centering, rotating, but the high density particle with very much energy, they will be rotating and it will be taking the space of outer area. Inner core will be low density particle. So high density means sand. So high density particle will be rotating at larger radius and rotating down. So what you are getting? Rotating down, at bottom you are getting sand actually, or the fluid will the sand will be going down, and fluid it will have fluid component also. And what happened to lightweight component? Component also will try to come down, but it will not get space. So what will do? They will be accumulating here. And what will they do? Take one pipe long like this and suck this low pressure fluid, okay. So low density fluid, not low pressure, low density. So this hydrocyclone, actually it is used in many places, in particle settlement, in environmental particle settlement, and many other places. Is very good for separation unit, because it is not having any moving element. Whenever you are thinking about any mechanical element, if you are having lots of moving element, the reliability or life becomes lower. So if you want to increase life of a mechanical element, so you have to reduce number of moving element. So in hydrocyclone, actually there is no moving element, you can see only fluid particle rotating, okay. But if you see any other centrifuge, like medical industry, they are using, so mechanically if you are giving rotation, the life will be lower, again you have to consume, you have to give some energy. But here you are using well bore fluid, whatever energy is there. So, same fluid you are giving at high pressure, high velocity, rotating continuously, you are separating two particles, life will be longer and is simpler, cheaper. Okay. So, normally it will be common for all environmental agencies, they will be using the particle separation process. Many industries will be using, and oil and gas industry also using as a hydrocyclone or sand separator, they say. Hydro means water. Okay. And disposal, again once you dispose all the particles, oil or hydrocarbon particle, then you can dispose anywhere.